Hi, my name is Endre Sara. I'm one of the co-founders at a company called Causely. Happy to tell you more about the company, but for now, I wanted to talk about both our experiences, as well as we are working with a large number of customers, leveraging OpenTelemetry, their experiences in how to use that instrumentation better, what are the challenges, and maybe going to a bit of a future of where I think this could evolve to, beyond just the current state of affairs. But let me start. Okay, wait, does this work? Okay, good. So at a high level, I want to start just to reference some of the current challenges that both us using OpenTelemetry and our software and our customers are experiencing in terms of how much data they are collecting. I think that the previous presenter was making a very good picture of the vast amount of data that could be generated, especially through OpenTelemetry. And I really want to focus on two topics afterwards. One is the importance of what I refer to as an ontology. It's an understanding of what is it that we are describing, what does our world look like, beyond just the raw data that we are collecting, and also painting a potential picture of how there is a possibility of distributing the processing of all of this data rather than collecting all of this information centrally. They're kind of building on each other. Hopefully most of this is not going to be new in terms of this slide. How many of you are using OpenTelemetry in production, instrumenting and monitoring your application? I assume it's mostly everybody. Okay. Some of you, I assume, are doing some self-hosted observability stack. Some of you might be using a managed stack. I guess maybe it's half and half, but I'm curious, like how many people use a self-hosted stack? Cool. In the case of your self-hosted stack, how frequently do you run into issues with like, I don't have enough storage, I'm running out of space, it's too slow, doesn't scale? Once a week, once a month, maybe more frequently. And in terms of the managed services, how often do you look at the cost of the egress, the amount of traffic that leaves your premises? I'm doing both, and I see personally the challenges in both of them. But at the end of the day, just purely collecting the data itself does not actually provide me with insight. So after all of these challenges, I still have to figure out what's actually going on. So there's this balance that people are trying to maintain in terms of how much data they need, how much data they can use, and how they are either able to scale their self-hosted stack or to be able to efficiently use a SaaS provider to collect and manage their observability data. So typically people end up looking at the standard current best practices of avoid collecting everything. There were several presentations today on how to sample your data. How many of you sample your errors differently than your production? How many of you collect everything? Okay. So the beauty of collecting everything is that you could look at anything, but then you're challenged with how well it scales and how much it costs and how efficiently you can get to the data. The problem with tail-based sampling and adaptive sampling is that you kind of have to be able to piece together the information afterwards. And what if there are things that are missing that you should have included in your sample, but then in hindsight you realize like, well, I never knew that was important. And this is especially important when you're trying to, actually that's my next slide. Anyway, the point is to be able to understand the behavior of your system. That is really our goal. We want to be able to reason about how our system works. I'm not in the business of collecting data or ingesting data. It is important to be able to do this, but at the end of the day, I really want to know how my system operates. What are the dependencies? What are the things that make up my system? What are the data paths, how data is flowing through my system? And rather than the raw data, I just want to know where things are slow, where things are errors, or where maybe my transactions have dropped, I'm being throttled, all these problems, which is somewhere contained in the data, but if you sample too much, you don't know what your error rate is. If you sample too much, you may not be aware of some of the otherwise healthy paths, healthy dependencies. So for example, just this last week, I was talking to actually a friend of mine works at a large financial organization, and he's developing AI models that are being used by their respective customers. And he was concerned how, as he moved these new AI models into these systems, it's not just the model itself, but all of the interaction between the components. They're putting a chat interface in addition to the search interface on to allow the users to interact with the system. It changes the user profile, it changes the pattern of the interaction, and how not just his individual models, but all of the components will perform. He could obviously try to throw this into production and see what happens, but how do you understand your system behavior? And when he talks to his observability team, the observability team is like, yeah, sure, we can collect more data. Can you give us a justification of why you need to collect more data? And my friend said, like, well, I don't actually want to collect more data. I really want to understand how this thing is going to work in production with these different models, with different AI patterns. So really, what I'm leading here is to be able to move from raw telemetry to an understanding of the components that make up your system and what their dependencies are. And first of all, I think that in general, semantic conventions are really foundational. Talk earlier was claiming, and I completely agree, it's probably the biggest benefit, the biggest gift of OpenTelemetry is to be able to have semantic conventions. But I'm going beyond that. These semantic conventions are enabling us to create an ontology, is to be able to understand what is what, not just having common labels that I can cross-reference data. And really the shout out, the call out I want to make is to the entities SIG, which is an amazing group of people. They are evolving, representing entities as a first-class signal, not just the traces, metrics, and logs, which gives us the ability to say that, like, this is this service, this is this other service, this is how they are related to each other, this thing is alive, this thing has been deleted. It's basically the identity and the life of the entities and the relationship of the entity as first-class data, rather than just what I think most of us do today as a label on a span or a label on a metric or on a log. So as the entities signal is evolving, we now have the ability to significantly more aggressively sample, for example, our data, because the entities can represent what it is that we are talking about. Entities' attributes can represent how this thing is behaving, instead of having to transmit that raw data into some centralized big data lake and to be able to process it afterwards. So really, semantic conventions, and especially the semantics around entities, can become a starting point for an ontology, is to be able to describe what are the services, what are the attributes, what are the relationships. Now, we have actually been doing this before this became a thing in our own product. So really, the reason I'm emphasizing this, because I think that the entity SIG gives us the opportunity to contribute, if not even the code, but at least the concepts. There are a couple of really interesting challenges in terms of how do you maintain an identity of something. So if you're running a Google Cloud, Google would say everything has like a Google identifier. But if you're running in Azure, it's in Azure. If you're running something in Kubernetes, do you use the Google ID? Do you create your own ID? What is the common identity of these entities is one of the first problems that the SIG is currently working on. And as data can come from multiple places, it's important to have entities as its own first-class signal to have unique and durable identities, at least for the life of that entity. But the next interesting question is relationships. This is evolving in the SIG, but I think it's really important to be able to represent the system as a whole, is to be able to semantically describe what those relationships are. And I think that at least from our experience from our previous company that I was a part of, is that you can start with a fairly high-level description of this thing is connected to this thing. This thing is composed of this thing. These are fairly common terminologies, I think, that, or layered over this thing. We can start with these high-level abstract definition, instantiate them as we are generating the entity signal. And for example, if I want to know that this Golang application is calling this Python application today, and let's say there are no errors, everything is fine, I would have to send all of the 200 spans to be able to know that service A is talking to service B. And to be able to know that it's 1% error or 99% error, I have to send some indication of all of those spans. What if we are able to represent service A and service B as two entities, a relationship between those two entities, and an attribute that says that, like, I have high error rates or I have high latency. We actually implemented this, and we want to take this concept, contribute it into the open source. We haven't done that yet. It should be happening, and incrementally, of course. But in our practical experience, our customers who are otherwise carrying gigabytes of data every second, mostly logs, traces, and metrics, after you transform them into entities, relationships, we are dealing with kilobytes of data or less. So huge difference in terms of the ability to scale, the cost of all of this, and actually, not coincidentally, the privacy of this data. Because if you're dealing with raw signals, you have to filter out the user ID and the account number and the other PII data. If we are able to turn these signals into abstract entities, relationships, and attributes, a lot of that PII data is not even a question. It will never leave the premises. Now, the current state of this is that there is actually a prototype implementation by Telemetry from the SIG that generates entity signals in the collector. But I think the direction is to be able to make this part of the SDK. So the actual application can declare itself to be an entity, emit those signals with all the identifiable attributes. I think in the short term, it's probably more practical to try to turn current instrumentation into entities in the collector, but that is still within a cluster or within some localized environment. And then as the SDK adopts these signals, then the instrumentation gets implemented in the applications is to be able to declare these entities and their attributes and their relationships as part of the emitted instrumentation natively from the SDK. Either way, I think that there are huge benefits of being able to reduce the data, to be able to scale the systems, to be able to manage more secure environments or private environments this way. I'm saying this from practice, but that is not yet in part of the open source code. One of the other major potential that this is, I'm probably going out even further than what the entities SIG current mandate is or plan is that once you have a understanding of how to reference data across multiple systems, multiple environments, multiple clusters, multiple clouds, different components, now you could not only understand that this entity refers to this entity, but also possibly localize some of the data. So maybe even the otherwise really important error traces or log messages will never have to leave a particular cluster or a particular edge location, because if I have a common way of referencing, it's like, this is the entity, I want to know the logs or the metrics for this particular time frame, I think that there is a potential of being able to keep that data local and really minimizing the amount of data that is centrally needs to be collected, or at least minimizing the amount of raw data that needs to be centrally collected. So what I'm proposing is to be able to offer, not as a ultimate Boolean, stop collecting everything, but as an alternative to collect less data, sample more aggressively, and have a path to be able to go back and query for more granular data or more specific data if you need to, with the common reference of the entities and their unique identifiers, or maybe through their relationships. We're also doing this in practice in our own code base, and I think it would be amazing to see this. Now, as a caveat, I'm sure someone would say that this comes with an operational complexity, because managing distributed processing, querying data distributed across systems is more complex. Not that a single join in a big data lakehouse has no complications, but obviously you're depending on more networking, more communication. But I think that this provides us with the ability to scale even further. And then that allows you to do even things like localizing anomaly detection, localizing the processing of the data in terms of whatever things that you want to be able to identify. Some of these things may already be done in the collector, but I think it would be too adventurous for me to suggest that all of this can be in the collector. That would be a bit of an overload. The collector, I think, does already too much. So I think that the discussion we were having is in the SIG last week actually, is that most likely if there was such an architecture, this would be some side service, some little time series database that could store data locally rather than the collector having to process this. And also, I think that the current OpenTelemetry protocol is already fairly busy just transferring signals. So if I want to have the ability to query additional data, that would probably be a different protocol and a different interaction to this database. But I think that those two things can complement each other, where the essential entity data and some data may be pushed out as today, and then for additional data you could come back and query some localized store, again with care for privacy and everything else. So this is pretty adventurous, and I'm really curious if anybody has any thoughts on like how far one would be willing to go, both in terms of maybe the more practical part in terms of the entity signal. I think that's going to happen because the SIG is working on this, and how far one would be willing to go in terms of like really distributing all of the processing and the raw observable data. But I'm really curious about any thoughts and feedback. Oh, right, and just as an example, so what we're doing in practice in our own production code is that we are taking advantage of auto-instrumentation, especially eBPF auto-instrumentation. And the first question that I get from people is like, well, that's going to be too much data. How are you going to sample this? Well, my answer is exactly what I proposed. An implementation of what we did is that we localize the data, we represent them as entities relationship, and we actually have our own protocol of querying this data. The input is still the same open source, OpenTelemetry, but instead of collecting all of that centrally, we can maintain the level of granularity with a full eBPF auto-instrumentation, or LD preload, I think, is a really cool way of auto-injecting instrumentation into applications without increasing the cost and running into scalability issues of actually being able to understand the behavior of all of those systems that are now instrumented. And of course, by better understanding the behavior of the system, make operations happy, make developers happy, have less problems, more reliable systems, which is what we all want. As just a summary of, focus on the behavior of the system, not on the observed data, understand entities relationships, focus on signals instead of the raw data, localize the processing, collect less, understand more. Any comments, thoughts, criticism? This is crazy, don't do this. I'm happy to talk offline to anybody as well about more details and examples. Yeah. Go ahead. Sorry, there's a gentleman behind you.
Just curious if you have adoption problems because of that limitation.
Yeah. So this is a really good question, and in our current product, we are shipping it built into our software, and most of our current customers are taking it with understanding of, we're explaining what it does and what the risks are. So. But there's a couple of things. First of all, technically, what we are contributing to and leveraging is Grafana's open source Bela, which was recently donated to the CNCF as which I think is the shiny new instrumentation, eBPF instrumentation, OpenTelemetry eBPF instrumentation project. First of all, the team is amazing, the community is amazing, but most importantly, it is very transparent in terms of what it does. You could look at the code base, you could, there is no secrets. If anybody were to try to write their own private eBPF code, it would be harder. Now, that doesn't solve all problems, but it's one cool problem. Open source instrumentation is important. There is also education around what it does, what it cannot do, what it will not do. So we had one of our customers in a regulated industry who said that well, I understand what it does, but I need to declare it as a third-party processor to my customers. Can you do that or not? So, of course, you have the option of not using it in our software. You could turn it off. But I think it is really hard, practically speaking, to expect every developer to inject up-to-date auto-instrumentation libraries, even just the auto-instrumentation libraries into their code. I think auto-instrumentation is going to become the future of how OpenTelemetry becomes pervasive and used everywhere. I mean, I'm instrumenting all of my code, but I'm kind of religious about this, so nobody has to convince me. But it's much harder for someone who is, that's not their primary job. So I think that this is the future, and how we collaborate and educate the industry and help people to understand and manage the risk about it is the future. Yes?
example, if the entity sig is, there, and now we can see sort of relationships between services and like maybe there's like an alert happening, right? Then the customer says, I want to dive into what's causing the alert. How do you sort of square that?
Yeah.
I'm not collecting every trace or whatever.
So what I said about should you collect everything or not, that was my personal opinion. I would not project that on the entity SIG. I just think that what they do enables me to make a point. But to answer your question, I think this really comes down to what is your purpose, which is both why I was quoting my very nice friend at a financial company. He is trying to understand system behavior and reason about system behavior, and he doesn't need to collect data. I think that the first keynote was also making the point about, hybrid cloud. Do we choose the cloud or not? Or do we focus on the application and the experience that we are delivering? I think this is a very similar argument that I'm also very religious about, is to focus on what is the problem that we are solving, and then what data we need, and where do we need that data to be able to solve that problem. So one of the things that we are publishing soon is what we call a root cause library. These are the problems that I want to be able to identify and prevent in my environment. And then once you put that down, it's like, okay, to be able to know if these things are happening in the environment, I only need this data. And there is no argument about like, why don't you collect more granular data? What is the purpose of that data? And I'm saying that like with edge processing, you could have access to more data, but still I think it should be with a purpose rather than just building a platform for infinite scale. And it's okay to disagree, if that helps. Thank you. Find me anytime, Endre Sara, LinkedIn here, and happy to answer more questions. Thank you.